Hello everybody and welcome to Chats from the Engineering Desk. Today we're going to have a quick talk about doing SMD soldering, which is surface mount device soldering onto PC boards. So what I've got set up here is the hot plate, which I've got 60 volts on. It's drawing 1 amp, so that's 60 watts. So that's running the hot plate at 130 degrees Celsius. So this board over here, once I've populated it, I'm going to put it onto here, and then once it's warmed up, I'm going to reflow to the hot air, which we have right over here, which is going to be running at 350 degrees Celsius. So what I'm going to do is zoom in on the board, and I'm going to show you how I apply the flux and the paste, solder paste, and populate it in the components. So there, I think you got a pretty good idea what I'm doing. So let's take a seat. I'm going to start off with the solder paste. Over here is our tweezers for applying the components over here. It's 3 op amps and several resistors. So what I'm going to do, gently apply some force to the plunger. I've had this out the fridge so this can warm up and flow, and it is somewhere here. Whoops, a bit much, not to worry. And get the paste going. What I can always do is take a toothpick or a Q-tip and just wipe up some of that excess. So that's those resistors done. So now I'm going to apply the solder for the op amps, like so. This is fairly low volume stuff that I'm doing. Make about 20 of them at a time. Normally one would use a stencil and screen the paste on, but this is low volume and low component count, so we're okay with doing it manually like this. And just carry on applying the paste like that. We're almost done here. In the beginning this is quite daunting. You worry about how hard is it going to be and what's going to go wrong and so on. And it's actually not that bad. Not at all. But the most important thing is you need the hot air for the reflow. Let's see. That over there is a connector, because what this board does is it emulates an op amp, which has become very expensive on analog devices. Op amp. So what we've done is designed this little board, which has got some Oppo 7s in it. It's a differential amplifier, and it it allows us to carry on producing this product cost effectively, because the analog devices op amp had become wickedly expensive, like in the order of $20 each. Now this product that this goes into is a strain gauge amplifier, which is why you got these instrumentation op amps that we're using here. So what I do have, if I do need to wick excess solder up, there's some solder wick, like so. What you do is you apply some flux to it, and then you heat that with a hot air while heating the component, and you just wick up the excess solder if you've got too much. So next I've got 7 resistors, 1 2K, which I'm going to place on the board like that with my tweezers, and then the 10Ks, which I'm going on like so. Let's see, yeah, you can see what I'm doing. I've got a magnifier on the go here, and I'm wearing some magnifying glasses so that I can see what I'm doing, because this stuff is tiny and it's minute. So we might have to do a bit of rework on that 10K, because the solder paste got a bit out of hand there. Right, now for the op amps. Let's keep them all turned that way. These are Oppo 7s, they're instrumentation op amps. And then over there, it emulates a normal 8-pin dual inline package. That I just solder on the connector, which is a through just pin standoff stops arrangement. So there I've populated the board, and I'm happy with the component placement. So what I'm going to do is transfer this to the hot plate. I'll give it a moment to warm up, and then we'll flow it. So what I'm going to do is move that over there, and bring in the hot plate. I'm not going to move the camera. What I'm going to do is that over there like that, and then you can see what I'm doing. And then move my magnifying glass so that I can see what's happening where I'm flowing. Now I'll show you the temperature. So there's the thermocouple. So I'm going to touch that to there. There we go. Now about 136. And I can see some vapor starting to come off that PC board as it's warming up, and I can also see the paste flowing as that warms up. So we are almost ready to fire up the hot air. So I'm sorry about the noise that the machine's gonna make. It's gonna hum and buzz and vibrate. And I'm gonna start the pump and turn it up to 350 degrees C. And once that's the air's up to temperature, then we can float and you can see the magic happening. What I want to do is just keep the flux on hand in case you need to use a bit of wick. So I'll put it ready over here. Right, we are ready. Let's do this. So there we go. Applying the hot air. And I can already see I'm going to have to wick a little bit there. You can see the resistor moving. That one's got a bit too much solder on it. We knew that was going to happen. They're flowing. None of them are tombstoned. Right. Now we've got a bit of cleaning up to do because we've got a bit much solder on things. So, take some of this wick. Apply a little bit of flux, like so. And let's suck up the excess. While keeping our hands out of the hot air. Come on. And of course got to be careful that you don't move the components around too much when you're doing this, because they're essentially floating on the solder, like I just did there. Hot fingers. Alright, let's do that one. And then over here, now there's that one. And over here, a bit of a problem with that resistor. There we go, that's better. So there you can see the solder that are sucked up with the wick. Now before I turn the hot air off, I'm just going to give this a look. Like so. And I think I'm happy with that. If need be, one can always dab a little bit more on with a soldering iron afterwards. That pin over there I can see looks a little bit dry, as well as that one over there, but that I can fix with a soldering iron. So I'm just going to run the hot air down, get it cooled down, and then we can turn off that and the pump. And then that's going to wrap up this demonstration of doing SMD work. So what I'm going to do as well is turn off the heat to the spiral plate. This is called 1/8" about 3mm aluminium plate that I've got over here as a heat spreader in the spiral plate, and I'm just using a bench power supply which gives me 60 volts and heats it up nicely. I leave it for about an hour before the time to heat up, and then once the little bit of rework has been done over there, then we have silence. It's a case of fitting the pins on the other side of this board and testing it, and then taking some isopropanol alcohol and removing the excess flux, which one can see over there. There's some over there. Clean it up and make it pretty. That's SMD work. This is pretty much the manual version. Fairly low component count and fairly big components, easy to work with. So with hot air and some basic sort of tools, you can do it in your own home, in your own kitchen. And I think that's going to wrap it up here, folks. Something different, doing SMD work. I'll put the paste and the flux back in the fridge, and I thank you for being here. Hope you enjoyed it and learned something from it. For the rest, have an awesome day further, ladies and gentlemen, and I'll be seeing you for more sometime soon. Take care. Cheers.